This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
For Software Engineering Radio, this is Robert Blumen. I'm joined today by Udi Dahan. Udi is one of the world's foremost experts on service-oriented architecture and domain-driven design, and also the creator of N-Service Bus, the most popular service bus for the .NET framework. Udi, along with Greg Young, is credited as co-founder of the Cqrs pattern, and that will be the subject of our discussion today. Udi, welcome to Software Engineering Radio.
Thanks for having me, Robert. It's a pleasure being here.
Would you like to add anything about your background that I didn't cover?
No. I mean, I've done a bunch of things in my career, but I prefer to keep it short and sweet.
Okay. Today, we will be talking about Cqrs. That is an acronym. Let's start out with, what does it stand for?
Cqrs stands for Command Query Responsibility Segregation.
We're going to go into that in more detail. I'd like to start out with the C part, command. This refers to the well-known command pattern. Before we go into the whole of Cqrs, would you please review the command pattern briefly?
Well, the idea of the command pattern is to take the idea of, let's say, a task in a system and represent it as an object in its own right, as opposed to merely having commands appear as, say, methods on some other object.
Could you tell us a little bit about the history of Cqrs and how it got started?
Oh, okay. So a number of years back, myself and Greg Young, we've kind of traveled in the same sort of circles. He has a blog, I have a blog. We read each other. We speak at a lot of the same conferences and interact both online and offline. In sharing our experiences with each other about the types of systems we've been working on and the types of problems that projects have run into, we found sort of a common theme of problems and a common approach that we dealt with them, where our general idea was, or maybe starting with the general problem, the problem that we saw was that often developers would use the same set of objects, both for commands in their system as well as for queries, and that often that ended up, in essence, pulling that set of objects in two different directions, that it was really difficult to come up with just one structure for those objects that would be suitable for both handling commands and queries. So, and each of us had tried independently an approach where, in essence, a different set of objects was created for handling commands than the set of objects that would handle the queries. And we both found independently that seemed to work out quite a bit better. And in talking to each other, we kind of verified our approaches and said, this should kind of have a name, this thing that it is that we do, and thus Cqrs was coined.
You said that having a different set of objects for your writes and your reads helps out. How does that help out with a system?
Mm-hmm. So, to be clear, this isn't for, let's say, trivial data-centric operations in a system. So what is often known as CRUD, the create, read, update, delete types of behaviors, which are extremely data-centric, take a bunch of data, store it in a certain table, or read it or delete it or update it. If there isn't very complex behavior and for a certain part of the system, then it often isn't necessary to apply CQRS approaches. However, when you have either commands or queries that are more complex in nature, queries that may require you to do more complex calculations and pulling in larger sets of data together, or commands that have both complex validation and business rules and other, I'm not sure if I'd use the word side effects, but other additional behaviors that trigger further things happening in the system later on. It's in those areas where there is the highest inherent complexity in the domain itself that CQRS starts to make sense. And in those areas, what we found is that, again, queries are often operating on a very large data set. They're doing complex calculations, but let's call it the center of gravity of how queries are handled, also in relation to the staleness of data that a user is willing to tolerate, is very different from when we're talking about command processing. When dealing with command processing and you have similarly complex logic, neither the users nor the stakeholders tend to have any type of sympathy for operating on stale data. That's when the really core business logic is being run, and it needs to be executed on 100% consistent, up-to-date data, and the results have to be 100% consistent and up-to-date. And on the query side, that's not needed as much. So caching semantics and data staleness and correctness and consistency stories are very different between these two worlds, the commands and the query side of things. And as a result of that, this is just, you could say, applying the single responsibility principle, that instead of trying to have one object or one set of objects do both, we choose to divide up these responsibilities and have two different sets of objects for it.
So the essence of this pattern then is you have different parts of your system which are responsible for doing writes and updating the single point of truth and doing reads that may provide slightly out-of-date data.
So maybe allow me to refine that statement a little bit. When looking at domains that have a fair bit of complex logic, we often see that there is some correlation. In my experience, it's actually quite strong, with that domain being very multi-user collaborative, meaning that we have large numbers of users that are both reading and writing that same set of data at the same time, meaning that when one user is looking at the results of a query operation, it is fairly likely that another user has gotten in and performed a command which changed the underlying data, meaning that user number one is now looking at a stale picture of it. So that element of staleness around the queries is a fairly significant element of it in a multi-user collaborative domain.
So when you're talking about this primarily as a way of breaking down responsibilities into objects, and when I began reading about this, what I saw, and maybe I've picked up an idiosyncratic view of what this is about, but a way of segregating load on the system into different data stores that might have different models based on how those data stores are accessed. To what extent is CQRS about distributing workload over different data stores that are organized differently?
So I'd say that it's strongly correlated with that, but that it isn't necessary to go all the way in that direction. When you already have the command part of your system that has to operate on 100% accurate, consistent, up-to-date information, and you have the query part of your system which can provide somewhat stale results, just that element of staleness is indicative that you could return information from a cache. Now, one could leave the cache as being a purely volatile in-memory cache, or one could decide to actually make that cache be a persistent cache, in which case the data structures, the persistent data structures behind that persistent cache would end up looking differently than the data structures that are supporting the command side. Now, I tend to recommend that people evaluate going down that path and being more explicit in their data modeling of their query needs, independent of the data modeling of their command needs. Because ultimately there's, the persistent data structures are going to have an impact on the kind of objects that access those data structures on top of them. So if you want to have a very clean, highly optimized command model, you will have the most ability to achieve that if you take more complete control of the data structures supporting those command objects and designing it specifically for those needs, rather than trying to have a single data structure that serves both the command objects as well as the query objects. Ultimately, this is taking the principle or the approach of Cqrs all the way down into the data persistence layer.
So to give an example then, right model might consist of a highly normalized relational data store. It might be persisted to a highly normalized relational data store, which is the most efficient data storage for very fine-grained updates, but read models might be denormalized or transformed into JSON or a format that's closer to the consumers of that data and requires less joining and reassembly of normalized data structures.
So I'd say that that's a very common way that relational database technology is used in systems that are applying the Cqrs approach, that the command side remains highly normalized and the query side is highly denormalized. That being said, if we were to take a step back and say, is really a relational database the most appropriate solution either for the command side or the query side, what we might see is that different domains have a slightly different nature to them. So there might be some queries that are much more graph related. So if, for example, you look at recommendation engines, for example, if you're on Amazon purchasing a book, they will show you customers that bought this book also bought these other books. That is very much a graph type of data structure with many-to-many relationships between all of these books and a certain kind of ordering of how many people bought this pair of books together versus that other pair. One could try to take that graph set of data and denormalize that into a flat set of tables in a database, in a relational database. It probably wouldn't be as optimized as, say, using a proper graph database for it. So, and also on the command side, there are areas where if you take a highly normalized set of tables where you have a command whose processing logic ends up touching records across a large number of those tables, relational database technology tends to escalate locks quite a bit more aggressively the more rows and the more tables that you have taking part in a given transaction. In which case it might be more optimal to have, say, a document database structure or a columnar store for certain types of command processing that will result in higher performance transactional processing of those commands. So ultimately I see a very strong symbiosis between NoSQL databases and the CQRS style of writing the logic on top of it.
We had a show a little while back about polyglot persistence, and this concept you're explaining is very similar with maybe a bit more of a overall vision of the system on top of it to what we covered on that show. So I'd like to come back to how, from an infrastructure level, the different data stores remain consistent. I want to change directions right now and talk about the relationship between CQRS and domain-driven design, which we've had a show on domain-driven design. Tell us briefly what domain-driven design is. Listeners who are more interested can go back and listen to our show and talk about why the close connection between those two communities, and is CQRS really an extension of domain-driven design, or can you use it independently as just a data distribution pattern?
Mm-hmm. Okay. So there are a bunch of questions in there. Hopefully I'll remember them all. If I don't, I'm sure you'll lead me to the ones that I missed. So domain-driven design, in my view, is a style of design that is highly collaborative with a domain expert, meaning that there is someone with a deep understanding of the objectives of the business and the nitty-gritty details of how things get done, someone who is able to effectively make trade-offs between different ways of implementing the same requirements, who is working hand in hand with the development team in coming to a software design that reflects those business objectives most effectively. There are all sorts of supporting patterns in this field of domain-driven design that have been becoming more popular and less popular over time. For example, the idea of the repository pattern and the use of object relational mapping technology, those have kind of waxed and waned over time in the domain-driven design community. But I'd say that the most fundamental thing is having that very strong connection between a true domain expert as opposed to, say, a go-between, like a business analyst who interviews a domain expert for an hour or two and then structures the requirements in some sort of whether that be use cases or user stories or some other structure, and then, in essence, provides that to the development team. So I'd say that that's probably one of the more important elements of domain-driven design as a philosophy, as an approach towards building systems, just getting those two groups more closely together. Now, and again, my view, my interpretation of what is important in DDD. Now, when we get into CQRS, I find that one of the things that connects very strongly to that is that idea of the command side in particular, focusing on, let's call it, a task-driven approach towards representing requirements. Okay? So whereas some, let's call it, more traditional or older style of development may have a user presented directly with a large grid of information where the user creates and reads and updates and deletes various records directly. In other words, the user directly is doing data manipulation. What I've found in my practice of domain-driven design and working with domain experts is that often there is the idea of a task, an identifiable set of behaviors that fulfill some larger business objective that a domain expert often speaks about, that if we represent that both in the user interface as an explicit thing, as opposed to just allowing the user to modify any set of data, that not only makes the users more efficient in their usage of the system, it allows us to provide higher level validation and better business rules around those behaviors. And that's where the Cqrs commands and the user interface-centric tasks and the domain-driven design business objectives all line up. So I'd say that that's probably, for me, where is the strongest connection between Cqrs and DDD is very much on the command side for the most part. It's having a domain expert speak in task-oriented language as opposed to data manipulation language, and then representing that both in the user interface explicitly and then in the underlying business logic, explicitly through Cqrs.
Within domain-driven design, there's a concept of what they call it a bounded context. I might call that a subdomain or subsystem. You're talking about how commands are applied to a given part of the domain. Within the command processing logic, clearly it has to be operating on the most current state that it's updating, but could command processing be reading from the read models of other subdomains that it uses for supporting data that is not being modified by that command?
That's an excellent question. I get that question frequently. My general recommendation is that code that is in a given bounded context or responsible for a given subdomain should not be querying data from other subdomains. Specifically, when it comes to command processing. Command processing is that area where often the business requires the highest level of consistency guarantees. As a result of that, reading from a somewhat stale read model from another bounded context is going to just work against that needed consistency. The second part, as I say, just gets back to single responsibility principle. If you have identified subdomains correctly and set up your bounded context or your modules, your set of objects that implements the requirements for a given subdomain well, then you should not need to query data that way from another subdomain. What can be a useful pattern in order to propagate information from one subdomain to another is the publish-subscribe pattern, meaning that the code that is responsible for a given subdomain, when it makes some changes to the data that it's responsible for, it can publish an event that would be subscribed to by code in other subdomains, which will then store inside them the necessary subset of information that they need, whether that is for the purposes of queries or for the purposes of command processing. But then we make it quite a bit more explicit in so much of saying, this is an event, this is what it represents, this is the consistency, this is how up to date the data is that I'm giving you. It helps developers think a little bit more explicitly about things like the staleness of the data in their system. What I recommend developers do anytime that they are applying the publish-subscribe pattern is to ask themselves questions with regards to, let's call it the validity period of the data that's being published. So if I'm publishing an event saying that a customer status has changed, that might be something where I say, okay, the customer is now a gold customer and that's forever. Or it could be that, like a lot of loyalty programs, that the status is valid for 1 year. And that if you don't hear an event within that year that refreshes that status, then that customer will lose that status. So this is not only useful for developers, but useful in the interaction with domain experts, saying anytime that I want to propagate information from one subdomain to another, let's have a conversation about the lifetime, about the period of validity of this information that we're propagating across. That will help the code on the receiving end know what to do with it, how long to do with it, and takes the business logic in a slightly different direction. So ultimately, these things are very these patterns support each other a lot. The idea of DDD subdomains, publish-subscribe, event-driven architecture approaches for getting information from one subdomain to another, and then the Cqrs code within a given subdomain that is using information from those events as a part of its internal processing. But let me just reiterate, I would strongly recommend against having command processing code in one subdomain directly query data from another subdomain.
Got it. At a high level, we have commands coming in, generating updates as they're processed, events that are published for other subdomains. We've also been talking about multiple data stores that may run on completely different types of servers that are getting delayed versions of the updates from commands. It sounds like there's got to be some underlying infrastructure that can move all these events around between the different subdomains and from the write model to the read model. Mm-hmm. What kind of underlying, is there an event bus or some kind of messaging system that you would build the Cqrs distributed system on top of?
So it's not at all coincidental that I ended up creating my own service bus technology. It is exactly for the reasons that you're mentioning, that I had been doing a lot of domain-driven design, Cqrs type of work, trying to keep or to synchronize and propagate events between subdomains, that ultimately what I found was that the message queuing technology that I'd used in the past, whether that's MSMQ, ActiveMQ, RabbitMQ, etc., the messaging technology was relatively low level, and I always had to write a lot of boilerplate code around the messaging APIs, whether it be at the level of transaction management, whether it be with regards to retry logic in case exceptions occurred while processing a message, be that a command or an event. So after a number of years of doing this, I created my own and started growing that organically, and that became N-Service Bus. I do recommend that developers that are moving in the direction of Cqrs, that have divided up their code across a couple of subdomains that are using these publish-subscribe patterns, do look at using something above just some sort of messaging middleware. Again, whether they create that themselves, whether they're using a free open source technology, whether they're using a commercial technology, there are a lot of little nitty-gritty things to get right. And the challenge that I found was that it's easy to get it wrong, but to have the wrong thing still appear to be functional. So if you get transaction management semantics wrong, when you are running the system on your own machine, everything's going to work fine. You're really only going to end up finding out that you have consistency problems when your system is under relatively high load in production. So these sorts of latent faults in your implementation can end up becoming quite a bit of a headache when you have to troubleshoot them in production. So it isn't trivial to get all these little things right. Definitely not something that a developer that's currently in the middle of implementing some really hairy business logic for a very complex requirement should be thinking about. They should have some sort of infrastructure there that gives them the safe by default behavior.
Would an example of that be events coming into the right model, serialized, applied in a consistent way to the right model, which is updated? It generates events that go out to one or more read models. Does each read model need to see the events in the order that the commands were applied on the right model in order for the read model to get updated correctly?
The answer to a question like that is it depends. There is some logic on the read side where it's quite possible that the order in which you do the processing of these events doesn't matter. There could be other cases where the order actually does matter. So before delving too deeply into the technicalities of the it depends, I want to reiterate something that I said earlier on, which is that the difference between CRUD-style data manipulation logic, where I believe Cqrs adds more complexity than it actually removes, as opposed to those areas that are much more task-oriented and have a fair bit of complex business logic in them. I've seen too many projects try to apply Cqrs on the CRUD data manipulation side of things and end up with a lot of difficulty over there. One of the challenges there that often occurs is even for a single user, so not necessarily in a collaborative domain, but if just a single user updates a record and then updates a record again. Okay, so they change an address field and then they change it a second time. Now, if you were to apply Cqrs, let's say in a somewhat naive way, where the command side say, okay, I got an update, modify it, publish an event, get another update, modify the record, publish an event. It is possible that you would have on the read side two threads that are processing those two events in parallel, in which case, it could be last one wins, but you don't really know whether the last one is the right last one or it happened to be the first one. Now, developers have come up with all sorts of techniques to work around this. For example, sequence numbers that are passed in from the client side when submitting these updates, and then the read side, which has some version checking behavior in there, so that it knows that it's applying the events in the right order. When I see developers concerned about the order in which things are being applied, it makes me curious if they are actually in a more CRUD data manipulation type of domain where Cqrs is probably overkill. And they should just forget about the two different data stores. They should forget about Cqrs having two different sets of objects for the commands and queries, and just have a single normalized view, just do traditional ORM-style data manipulation on top of it, and be done with it. So if you see that you're having issues with regards to the ordering of things for just a single user interaction, it could be that you are in a much more CRUD data manipulation domain, in which case you shouldn't be using Cqrs to begin with, by and large. But now, back to assuming that you are using Cqrs in the right place and that the problem domain justifies itself, and now you are concerned about the order in which events are being processed. That's an area where I'd say before getting mired down in the technical side of things, that's when you bring your domain expert in and you need to have a conversation with them. Because it could very well be that these two events that are occurring are as a result of two independent users or two independent actors that have submitted two different commands. And now the question is, really, should the fact that one user submitted their command a millisecond before the other or a millisecond after the other have such a big impact on how things are processed? and potentially the requirements need to be adjusted to address this sort of inherent concurrency in the domain better. One of the ways that manifests itself is by having, let's call it, clearer tasks or more granular events that you don't run into the problem of concurrency in applying them. So I'd say, first and foremost, go back to the domain, have a discussion with the domain expert, understand the collaboration and whatever conflict semantics there are that are inherent in that domain. Try to model that as directly as possible without getting bogged down in the technicalities of event processing ordering. And if you go through all of that and you still have an issue with the event ordering, then that would be a good time to apply sequence numbers, date time stamps on your events and handle it at that level.
There's another very commonly affiliated pattern or architectural model that is discussed on a lot of the Cqrs blogs called event sourcing and the event store. Talk about that and the connection between event sourcing and Cqrs.
Mm-hmm. So Greg Young is probably the best person to give the most authoritative answers with regards to event sourcing, and specifically with regards to the event store, which is the persistence technology that he created in order to support the event sourcing programming style. So my view on it, and this is based on many interactions with Greg, so I believe it to be a highly accurate representation of the thing itself. Event sourcing is a style of implementing your business logic as well as your data persistence, such that the current state of the data in your system is not stored as is, but rather the series of deltas or interactions over time that brought the system to the current state is what is stored. Okay, so event sourcing to a large extent has a very strong statement with regards to persistence. Ergo, its very strong connection to event store, and the reason why Greg ended up implementing the event store. Ultimately, he was creating a persistence technology to solve or to address his approach to writing code in much the way that I wrote nService bus in order to address my need to do publish-subscribe between subdomains. So you have this style of persistence where instead of storing the current snapshot of the data of the system, you're storing the history of how we got here. In addition to that, this is where the event sourcing programming model comes in. Because your objects, your business logic, does not have the current state of the data as it is right now, what you do instead is that the objects are, in essence, replayed that history of events from either the beginning of time or the last snapshot, which brings them to a current state, and then the new action is applied to them. So it is a very focused way of both dealing with history and current interactions and persistence that all align together with each other. Where one of the touted benefits of event sourcing and event store as a persistence technology when doing event sourcing is that the system, in essence, has a built-in audit log of everything that happened, which is very attractive to a lot of people. However, I'd state that the ability to achieve an accurate audit log of a system is, it's equally accessible to people that are not doing event sourcing. So if you're doing, say, just a traditional REST type of API that is using an ORM behind the scenes to talk to a relational database, you could have some generic HTTP handling code that every request that comes into the system, any HTTP action with the headers and all of its bodies, is persisted to some data storage. If we're talking about message queuing technology, similarly, lots of message queuing technology has auditing, or sometimes they call it journaling, built in. So auditing is a very good thing to have in a system. Event sourcing and event stores also provide it, but they're not the exclusive providers of it. My view as to where event sourcing makes sense is, similarly, as I said before, if you have a CRUD data manipulation type of domain, neither Cqrs nor event sourcing are appropriate to apply to that part of the domain. So you want to be in a relatively rich business logic, task-oriented kind of domain. Another area, so within that category of problem domains that are fairly complex in nature, I'd say that if you have a domain that is highly time-oriented and is sensitive to history, so I'd say probably one of the better-known domains that exhibits this sort of property is that of payroll. So when you have bitemporal domains, they're called, where there is the time at which something occurred and there's the time at which it was known in the real world, and that there's different semantics around that. So, for example, in payroll, you may have received a raise 3 months ago, and however, it was not actually recorded 3 months ago. You found out a month too late that the raise was not actually entered, and that the money that was deposited into your account was not enough. So you go back to payroll in the company and say, hey, but I got this raise, I should have gotten more money. In which case what they will do is, in essence, they replay history. They say, okay, if you had gotten the raise, if the message about giving you the raise had come in at that time, then we would have played the payroll calculation this way, resulting in this much more money, and then that event that comes out of how much more money you should have gotten, that feeds into this month's payroll, and then that's how we influence the calculation. So if you have a domain like that, where this element of replaying history is very core to the business logic, then I'd say event sourcing is a very good approach. It's extremely appropriate, and it will probably be much better than if you tried to write that business logic without an event sourcing type of approach. However, if you have a domain where most of the business logic is really only ever operating on the current set of data as it is right now, event sourcing is probably going to be less optimal for you, and that there is a simpler way of writing that code.
Okay, thank you for that. That was a summary of event sourcing. Now, I'll tell you how I've understood the connection between Cqrs and event sourcing, and you tell me if I've gotten it right. Mm-hmm. The commands come in, they're processed in your your command handler generates update events for the write model, which may generate further events now propagated through the event bus or event layer out to the different read models. The read models are replaying events, but they're transforming them in a different way to produce appropriate read models. The read models are therefore inherently derived data. You could, if you wanted to, let's say, change the data model of one of your read models, blow it away, replay all the events, and have a new read model. They're ephemeral. They're much easier to change. If you want a new type of search engine or upgrade, you could replay the event trail into the new data store, and all the complexities of migrating state are handled by this approach. Did I get that right?
So I disconnect some of what you said just now from event sourcing. So first of all, what you described is you have the Cqrs part of it, where as a result of processing a command, an event is published and propagated over to the query side, which then processes that event and updates a certain number of read models. That's just CQRS, or one style of CQRS where you choose to have distinct data models for your command processing side than your query processing side. Okay, you can absolutely do CQRS with just one data model, in which case you would not need to have an event be emitted from the command side to go over to the query side. All right, that's perfectly reasonable. Now, the second part of what you said with regards to the read model, the query side, saying that given that we have a audit of all of the events that came into the system, we could replay that entire history of events in order to create any read model of our choosing. Okay? That allows us to discard a read model if we want to. Sometimes Greg mentions that this is useful in the case where we had a bug in our system and we ended up showing the wrong data to our users. Being able to go back in time and replay things correctly allows us to, in essence, undo any incorrect things that were in there. I would, however, take that with a pinch of salt and be very careful in talking to my domain expert and saying, if I showed incorrect information to my users, where this could be users, or it could be that this is information that is exposed via an API to other systems. If we found out that there was a bug in our system, we would be extremely careful in trying to track down, well, which data was incorrect, which consumers had received that incorrect information, what actions might they have taken off of the back of that incorrect information. And in my experience, that's something that we tend to do very carefully, even before we start thinking about rebuilding that read model. So that there are some significant business ramifications that need to be talked through. And developers shouldn't so quickly rush to blow away, in quotes, the existing read model and rebuild it from scratch every chance that they get. Now, again, back to this element of event sourcing versus event-driven processing and the ability of having a built-in audit log. The history of all of the events that came into the read model is something that can be audited independently of event sourcing. Okay, the event store persistence that Greg created has some very nice features that make it quite a bit easier to create a new subscriber or a new read model that consumes the audit history and then is able to continue off of that audit and process the regular stream of events without any code or configuration changes to it. Okay, so that is a very nice feature or style that is used in the event store, but that isn't necessarily something that is directly related to event sourcing. Okay, so the majority of what you described is, I'd say, traditional CQRS in nature, much more so than event sourcing in nature. I know a lot of these things end up getting mixed up all the time. It's a problem.
Yeah. Okay. So maybe I have in my reading, in my mind, muddled together or merged between CQRS and event sourcing, which solve different problems, can be used for different purposes separately or together. You are covering this a little bit, but just to really, if somebody like me came to you and is experiencing this confusion, what is it I might not be getting about the difference between these two and how to figure out whether I need one or the other or both in my system?
Mm-hmm. So I'd say the biggest missing piece in my experience is the domain expert. It's having someone that you can actually put questions to. So, for example, when I said, is this a domain where it is frequent for us to have requirements where we need to, in essence, replay history as a core part of our command processing logic? This is not something that we as developers can necessarily come up with ourselves. So something that domain expert can tell us. I like using the payroll example because it's something that a lot of people who are employed in companies have had firsthand experience with, and they can understand the concept of replaying events as a part of core business logic. Okay? So I'd say take that example, get a real domain expert, say, can you see in the coming 6 to 12 months something in the domain that is reflective of that has that sort of nature to it? Because if so, then we should be looking towards an event sourcing model for these types of objects, and that will serve us well. Now, surrounding that, there is probably going to be some element of CQRS to it, but I wouldn't necessarily get overly tied up with having a different query model that comes out of that. It could be that the simplest thing to do would be to just have the queries go off of the exact same persistence technology as the commands are processing, and probably 90% of the time that will end up with a much simpler solution, a whole lot less code. So I'd say start there in terms of, should I be applying event sourcing? I would say that there's a very strong overlap, and I mentioned this earlier, that you will tend to find a good use of event sourcing in a domain that has a great deal of command processing complexity to it, meaning that CQRS is already a good choice over there, and that this is not a very simple standard data manipulation CRUD type of environment. Okay? So in that area, I'd say, and it also explains why there is so much overlap and confusion between event sourcing and CQRS, because both of them are applicable for domains with similar complexity signatures, if you will. And both of them are inapplicable in the CRUD data manipulation domains. Okay? Does that help?
Yes, thank you. That does help very much. One other question I have, which is a bit tangential, in looking at the blogs and discussion groups around CQRS, it looks to have gained a lot of traction in the Windows Enterprise area and Microsoft, but not so much in the Linux and open source world. Do you have any thoughts on why that is?
So I think that it started on the Microsoft side because both me and Greg, that was our background. With regards to it sort of gaining popularity there, to some extent that was driven off of myself and Greg blogging about it and speaking at conferences about it, which were, again, primarily conferences frequented by more Microsoft developers than those of other platforms. However, recently I've started to see a lot of interest from the Scala community and akka in particular with CQRS. And I'd say that there is a very strong overlap with, let's call it, actor-style programming as well as functional programming languages, in that functional programming languages tend to, as an approach, have this style of programming which is much more explicitly, let's call it, command-centric in nature, which allows them to be much better parallelizable and get better performance. So I wouldn't necessarily say that it is something that is only applicable to the Microsoft stack. I think that there's that there are certain elements of this pattern that make it attractive to functional programming or actor-based programming approaches, which we're actually seeing a whole lot more of not on the Microsoft platform, and CQRS is making strides there, as is event sourcing. But you know, to answer the question as to why we haven't seen that, you use the term open source type of programming. I differentiate, say, use the term Windows Enterprise. There could equally be Java Enterprise, and I think that it's equally appropriate over there. But I don't see that there's anything inherent about an open source or even if it's non-Microsoft but still commercial, like an IBM and HP environment, that would make it not suitable there. I think it's just a function of lineage. Me and Greg kind of starting in that area. Nothing more.
If listeners would like to learn more about CQRS, what are some of the resources out there that you recommend?
Well, I'd say definitely my blog, udidahan.com, udidahan.com. There's Greg Young's blog. I don't remember off the top of my head the URL. We'll put that in the show notes. There are a bunch of other people that have been blogging also about CQRS and event sourcing and all those styles. And you have read a bunch of those blogs as well, and you've gotten confused to some extent as to where CQRS ends off and where event sourcing begins and those kinds of things. So I am somewhat hesitant to point to the other ones. Microsoft a while back did a CQRS journey project that is something, if someone is a Microsoft developer, that can be an interesting set of documents to read. Not so much it being an authoritative source of information of CQRS, but as a kind of case study of a group of people that tried to apply CQRS to a domain and the challenges that they uncovered in the process. Specifically for them, it was applying it in the cloud. The whole issue of the need for supporting infrastructure versus rolling your own on an as-needed basis was one of the conclusions that they came to in that Microsoft project, that actually a fair bit of infrastructure is very desirable to have rather than trying to re-implement the wheel. It's very time-consuming and difficult to do right. And of course, both myself and Greg teach on the topic of CQRS and domain-driven design for people that want to learn more about domain-driven design in general. And I strongly recommend that. I think that a very good division of subdomains and bounded context is extremely useful. I might even go so far as to say necessary to apply CQRS well. So learning more about domain-driven design, ultimately you go to the source, go to Eric Evans, take his classes, read the book. Von Vernon recently has put out a book called Implementing Domain-Driven Design, also some very good information in there. So I'd say there's no shortage of information out there on CQRS. The big thing that I reiterate from what I said earlier, get access to a domain expert, someone who can make meaningful trade-offs around the definition of the requirements. Work with them to divide that big domain into smaller subdomains. That requires practice. Okay, it's not just reading, it requires a fair bit of practice. The more you do it, the better that you get at it, the more your intuition develops towards finding these sorts of boundaries. And absolutely, like I said, go to training, my course, Greg's course. In terms of supporting infrastructure, there's Greg's event store persistence technology. That's at geteventstore.com. And that's multi-platform, by the way. And there's my in-service bus technology, which you can find at particular.net, as well as a whole bunch of other tooling around the service bus that helps modeling and designing and debugging these sorts of systems to be quite a bit easier. So that's what I
was great, Udi. You just now gave me the whole show notes. Everything there will be in the show notes. You mentioned your blog and Service Bus. If listeners would like to follow your thoughts, are there any other places that you publish to or write to that you'd like people to check out?
No, I primarily, or when I find the time to blog, then I'll be blogging at udidahan.com. There's also the particular.net blog, but if anything, that would just be sort of a cross-posting.
Okay. Well, Udi, thank you very much for speaking to Software Engineering Radio.
Oh, it was my pleasure. Thanks so much for having me.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE Radio, or search for the Software Engineering Radio group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.